In this video, we'll talk about an application of triple integrals. One thing that we should note is that the corresponding interpretation of a triple integral, so the triple integral over the region E of f of x comma y comma z times dv, where f of x comma y comma z is greater or equal to 0, is not useful. And this is because this would be a hypervolume. So this triple integral would denote the hypervolume of a four-dimensional object, which is very difficult to visualize. The triple integral over the region of f of x comma y comma z times dv can be interpreted in different ways in different physical situations, depending on the physical interpretation of x comma y comma z and f of x comma y comma z. In the special case where we have f of x comma y comma z that is equal to 1 for all points in the solid region E, then the triple integral does represent the volume of the solid region E. So the volume of the solid region E will be equal to the triple integral over the region E of dv. And we have that the triple integral over the region E of dv is equal to the triple integral over the region E of 1 times dv. So we can write that as that. And then this is equal to the double integral over the two-dimensional region D times the integral from u1 of x comma y up to u2 of x comma y for z times dz, and then times dA. So this is equal to the double integral over the region D of u2 of x comma y minus u1 of x comma y times dA. And this represents the volume. This double integral represents the volume that lies between the surfaces z equals to u1 of x comma y and z equals to u2 of x comma y. Let us see an example. So we are given the triple integral, so the integral from 0 up to 2, and the integral from 0 up to 2 minus y, and the integral from 0 up to 4 minus y to the square dx dz dy, and we're asked to sketch the volume that is given by this integral. The solid region E, which can be derived from this triple integral, is a set of all points x, y, z, such that now we see that y takes values between 0 and 2. Z takes values between 0 and 2 minus y. And x takes values between 0 and 4 minus y to the square. Therefore, this is a type 2 solid region with a type 1 plane region. And if we want to sketch that volume of the solid, we have x, y, and z. And essentially, we have the cylindrical surface x equals to 4 minus y to the square that lies in the first octant because it is bounded by the planes y equals to 0, z equals to 0, and x equals to 0. So we have the solid that is bounded by the three coordinate planes, so it belongs to the first octant. We have the cylindrical surface x equals to 4 minus y to the square that is bounded by the xz and yz and xy planes, and it is intercepted by the plane z equals to 2 minus y. So this is the volume of the solid that we are asked to sketch.